Welcome back. So let's dive deeper into how do you start utilizing this cluster for creating your Spark jobs. So first up, since this is running on the Google Cloud, whereas we want to be able to control this from our laptops, it's important that we arm ourselves with the right tools in order to debug quickly, as well as to have the Jupyter Notebook interfaces up and running in our local machine without having to log into a remote cluster or remote machines. So to do that, if you go into the cluster tab, rather if you go into the details of the cluster that you've created on Google Cloud, there is a specific tab called Web Interfaces, and within that you would see various component gateways for all of the core Hadoop services that are running within Dataproc, including the Jupyter Notebook optional component that we wanted installed. So here, in order to use all of this, you've got to create an SSH tunnel from your machine to the Dataproc instance. So if you click on create an SSH tunnel, you've got three machine types, the standard operating system types that are typically there. Since I'm using a Mac, I'm going to use the specific command that Google has helpfully given to me. So there are two parts to this. The first is the tunnel needs to be established at the SSH level. So I've just done a copy of this command. If you notice the project name, rather the project ID is specific to the project that I am working on, as well as the cluster name is specific to the cluster that I've just created. So therefore, these commands can be directly copy pasted. You don't need to edit it per se. So I'm going to go to my terminal. I'm going to create a brand new terminal window. I want to ensure that the previous versions are all killed so that that's not disturbing me. Okay, yeah. So let's use a brand new terminal. So here I'm going to paste the command that I just got from Google Cloud. So once I press enter, the SSH tunnel gets created. We'll just wait for an acknowledgement message coming from this, and then we will proceed with the next step. One quick way to check whether the tunnel is up and running is to go back and start connecting to the web interfaces through the proxy that we just created. In this case, it's using Chrome as the browser for connecting to the web interfaces. I've got Chrome installed on my machine, so I'm going to use this. So I'm going to open a new window and click on this. Yes. So as you can see here, it's as though I've got a direct access to my cluster, various ports within it, and this particular port is what's called as the Yarn application master, and this is one of the interfaces that are very useful for debugging Hadoop programs. So I've got access to that now on my Chrome running on my local laptop, connected through the shell, right? So connected through the tunnel, SSH tunnel. Since I've used the cluster for last few days, so there are a bunch of jobs that are already there, but most of them should be finished, I believe. Okay, a few of them are running still, and it's very likely because these are existing Python notebooks which have been left running from my previous attempts. So we can go ahead and kill them, or let's leave it as it is. We'll launch a new Python notebook and we'll see what it comes up with. So this is the Yarn application interface. Likewise, you can take a look at the other interfaces which are necessary for us to debug programs. So let's straight away go to Jupyter. I'm going to copy this link, come back to Chrome, because Chrome is the one that's set up with this proxy. I'm going to paste the link here, and as you can see, it's directly connected to my project along with the reference to the Dataproc cluster to which it's connected, where it's installed. So here, by default, it provides access to creating or retrieving notebooks from GCS or the local disk, which is your local laptop. I'm going to click on GCS. There are a bunch of notebooks that I've already created. So let me just go ahead and open this. But before I do that, I just want to make sure that none of the other clusters are running. So good, none of it is running. So there are a few earlier instances of the notebooks, but they've all been, they've not been shut down. So I'm just going to go ahead and shut it down. So if you remember, there were 3 applications which were running here. So those 3 were basically 3 Spark notebooks, rather 3 Spark kernels attached to the 3 notebooks that I just shut down. So now if I come back and refresh this page, you'll see that those which were running have now finished. So there's still one more running, that's probably the root, right? So it's running 0 containers, yeah, okay, so which is good to go. So no more notebooks are running, so I'm going to start afresh. So for the purposes of this specific example, we're going to take a look at a sample data which is available on a GitHub repository. So let me show you what this data set looks like. So I'm just going to go here. Yeah, so this is the data this is the data set that we're going to use. It's available, it was created many years ago, but that doesn't matter. It's available in this particular GitHub repo. You can pause the video and take a look at the repo yourself. But the key part is that in practice, when you start working with real world data sets, you're going to get access to data sets in this specific manner, which is, GitHub repos which have the data sets stored locally, or it could be drive links from either Google Drive or Dropbox or OneDrive from Microsoft, or it could be Amazon S3 buckets, etc. So being able to work with a variety of different types of data sources is going to be a key requirement of how you work with big data projects. So in this case, I'm going to refer to data sets which are stored here in this GitHub repo. Specifically, there is only one CSV file that's of interest for me, and that's this one here. It's got about 3+ MB of data. So what I do is I want to make sure that I'm not downloading it here locally. The reason being, even though it's only 3 MB right now, I would still prefer if everything were to happen between GitHub as the service provider and Google Cloud as a service provider, and not have to use my internet, right? Because in many cases, as some of you would know, if the data were to be downloaded to my local machine, it's going to traverse my internet, and then when I upload it again, it's a waste of internet bandwidth to put it back into the cloud. Instead, if the 2 services can talk to each other, that's the best, right? So that allows me to move faster without having to be constrained by my internet choices. So what I'll do here is I'll just ensure that the URL is pointing to the file directly, or in other cases, if you have a folder of data, it should point to the folder directly. And I'll just copy this. And once I do that, I can go back to the Google Cloud console and open up something called as a Cloud Shell. A Cloud Shell is a temporary VM virtual machine which is provided for free by Google Cloud for every user who's working actively. So the Cloud Shell is a very simple low-fi machine. It doesn't have too much resources, but it's good enough to execute what are called as control plane commands, which are basically commands to start, stop clusters, execute various command line invocations for setting things like principals, managing resources, etc. And for small data sets like what I'm playing with, which is less than 5 MB, the amount of space that the Cloud Shell typically provides is usually enough. But the moment you get to the orders of tens of GBs, you might need to do whatever I'm showing you now as in a dedicated virtual machine, right? But you might need to spin up a temporary virtual machine, do the things that I'm going to just mention to you now, and you can shut it down after that. That way, you can still benefit from the Google Cloud environment, talking to the data source provider directly. In this case, a GitHub repo, without using your internet. Anyway, I know the URL now. So what I can do is simply, let's say, create a directory in which I'm going to store this. So big data intro samples data. So within this, just making sure it's empty. So I can use a command called wget. It's one of the core utils that Linux provides. It's useful to just download entire URLs. So I've copy pasted the link, and once I do a wget, it downloads it locally into that Cloud Shell. And as you can see, it did it extremely fast, right? So usually there is no, or rather there is lesser of an internet constraint between two large, service providers like GitHub, which is Microsoft owned, and Google. Okay, so I can just ensure that I've got the file. Okay, so let me ensure also the size is all right. So in this case, the size doesn't seem to be right. It's 225K. Let me ensure the data is there. Yeah, so it's actually downloaded the HTML, not the direct file. So which means I've copied the wrong URL. So let me go back here, ensure that the URL is right. So if you see, there is a difference between this URL and this one, I believe. So I'm going to copy the link to the raw file, and I'm going to try this again. Yeah, so now the data set is actually 3.17 MB. Because this file already existed, it's created another file with a .1 extension. Let's compare the two files. There we go. So 225K versus 3.2 MB. So I'm just going to remove the earlier downloaded file, and then move this file to having that same name, right? So that there's only one file which has just got one name, and that is of the right size. Now let's just quickly take a look at what this file contains, just to ensure that there is data. And again, I'm going to use a Linux core util called head. There are too many rows here, so I'm going to just look at the first row. The first row is comprised of the column headers in this file. Since it's a CSV file, the author of the file has helpfully provided the column headers as well. So let's take a look at one of the data rows included. So I've printed the first two rows in the file. So there's the header, and then there is the data rows. Great. So this looks fine to me. Let's just count the number of rows in this file. So again, I'm going to use a core util called word count. The flag -L allows it to count lines as opposed to words. So there are 8714 lines in this file, and if you remember, the first row is a header row, so which means there's 8713 data rows in this file. Super. So that's how I've downloaded this. You can go ahead and close the shell at any point in time. If you want to open it again, you can just click on activate shell, and it picks up from where it left off. So you can go back to, for instance, previous commands, etc. And if you can look at command history as well by just typing the word history, and you'll get all the previous commands that you've downloaded, that you've got. So now that I've got the file downloaded locally, there are two ways to get Dataproc to recognize the file. One, you move it explicitly into a Dataproc cluster, but that's not the right thing to do, because Dataproc itself is never going to be the storage of data in a persistent manner, whereas the other service which we are used to using in the previous assignments, that's the GCS service, is where persistent data needs to reside, or it could be, of course, tables and databases, etc. But for this example, I'm going to use GCS. So let me quickly move over to Google Cloud Storage and show you what the configuration looks like. So here the storage APIs have already been enabled, otherwise you would have got a reminder at this stage. Yeah, so here I've got two Dataproc related buckets which have been created. These have not been created by me, these have been created by the Dataproc cluster that was set up. Then I've got a notebook samples bucket that's been created. This was for the Jupyter notebook and notebooks that I've started to work with. I'll come back to this in a minute, but you can go ahead and create your own bucket for that. Where the data is going to be placed, I've created a bucket called Big Data Intro Sample Data. So within this bucket, I've already created input, output, and output 2 folders. So these are for various examples I'm going to show you in this videos. But input is where the data is going to be placed. So within input, let me just click through and I'll show you the data has already been placed here in prior to the video. But if you want to do it right now, it's fairly easy. You can say Google Cloud, G Cloud storage, and provide the details of what you want to do. In this case, I want to take this file and upload it into this bucket. So you would take the file name that you want to upload. So you'll say G Cloud storage copy, and so and you would then give the file name and then provide the destination bucket. The destination bucket is obtained by looking at here the input folder. So the input folder, if you go click on that, 1 second, let me go back to input folder. Yeah, so oops, there we go. So I've got the path copied from here. I've just directly pasted it here, and that's all that command is required for taking data from the Cloud Shell and putting it into the GCS bucket. Since I've already done that, I'm not going to change that again. So let me cancel this command. Now the data is available locally, so it's time to start playing with the data. So again, I'm going to pause at this stage. I'll see you on the other side of the break.